Working with arrays is pivotal in computational numerics, and functional programming offers us another way to do it. For example, if you are using the imperative style, such as this Python code that I have, you might define an array that's all zeros or maybe an empty array, and then in a for loop, you would either append or mutate the array such that you get the output you would want. However, in the functional style, you would take the whole array as an input to a function that would output the array that you want. This is very similar to how math normally works with functions, which is why people can often get caught up in category theory and all that crazy stuff, but we really don't need to go there. It's just a more natural way to represent the math that we're already doing. The two array operations listed here, map and init, will cover a lot of use cases, so I'll go more in depth on those ones. But when we hop over to code, I'll also show a few examples of other higher order functions. The first function we'll go over is Array.init, which takes in two parameters. One is an integer that determines the length of the array, and the next is a function that initializes each element. And the top two lines are equivalent, just different ways that we could pass them in by using the pipe operator. We can also use ID, the identity element, to just return the index number. But the more typical way we'd be doing this is with the lambda function, where the parameter I that we're passing in really is just the index number. And we can see the output of that would be the two arrays multiplied together element-wise. And just to reiterate, this works really well when your function takes in an integer as a parameter. But that's about it. Otherwise, we need to move on to the next one, Array.map. Array.map is a lot more general because you can pass in any function that will transform whatever data you have in some way. You can have an array of strings and your function can do something with the strings. You can have an array of floats and whatever. And map will handle all of that depending on whatever function you're applying. So it's a lot more general. In my opinion, this is a lot more intuitive than the imperative style where we would use a for loop, and then in that for loop we would index some input array, pass that value into the function, take the output value, and append it to some new list. We don't have to do any of that here. We just have a function that gets applied to each element of our input array, and that's put into our output array. Now let's hop over to some code to see this in action. In F#, a basic range of numbers is represented using this ... notation. So if we were creating an array, we can give the initial value ... the final value, or if we were slicing an array, we could do the same thing but with integers instead, initial ... final. Also note that everything is inclusive in F#, so if we wanted to index the last element of the array, you have to subtract 1. So let's run some of these. Okay, so that created our array. The next one gives us 0 plus 9, which equals 9. Good. Now let's slice an array 2 through 6. So it actually gives us that last element, the 6th one, and a quick list comprehension squares every value. Okay, with the basics out of the way, let's see how we can use arrays for some basic statistics formulas. The first example, the standard deviation, requires us to find the length of our list and then the average of the terms in the list. And then once we have that, we can subtract the average from each element of the list, square that value, and then sum over everything to return a single float value. Alternatively, instead of doing a map and then a sum, we can combine these operations using the fold. But with the fold, we have to pass in an initial value, which would be 0. And then this a term is an accumulator. So it'll perform this operation, pass that in as a for the next element in the array, and repeat that over and over. And then finally, after we do everything, we take the square root just to complete the formula. But the real pipeline action is happening here. Or here. So you can get clever using different higher order functions, but this also shows that you can get away with just using map and sums in a lot of places. Going on to the next example, the correlation coefficients, we use a very similar process. So we have a map, where we subtract the mean, square it, take the sum. So this could have also been a fold. And then doing the same thing for the numerator. So it's just a different equation, but this one takes in two different lists. So we have to use a double pipe operator and then the map2 function. And A here would correspond to each element of X, B would correspond to each element of Y, and then we perform the operation as follows. And once we assemble this new array, we can sum everything in the array. So like I've been saying, these two procedures can be combined into one using fold or some other thing. I don't know which one would be better performance. These run so fast that I don't think it really matters too much here, but you could play around with things like that. And tying all this together, we can calculate the covariance matrix if we have a bunch of samples from some distribution. And for this one, I wanted to use mathnet.numerics just to show how it works. Like if you wanted to calculate eigenvalues or do some other stuff, you probably want to use actual matrices and do some matrix math. But it works exactly the same as arrays. This could have been an array 2D if I didn't care about it being a matrix, and it functionally would have been the same. I would just replace this keyword. So what's going on in this function? I'm passing in an array 2D, which we can define the type annotation as float bracket with a comma inside. And then I'm finding the length of that array that I want if it's not symmetric. So there's dot length 1 and dot length 2. And then I'm creating a matrix. In this case, it's a square matrix of that length. And for each element in the matrix, the ith row and jth column do this formula to determine what it is. So it is effectively like for I in range and for j in range and do this. And so what's actually happening in here is I'm slicing the input matrix. So star gives us the entire row or column. So in this case, this is every row at the ith column. I'm taking this array, piping it into our standard deviation formula, and doing the same thing over here, but with the jth column. And then the correlation coefficient takes in two arrays. So we take the ith column and then the jth column as our two inputs and calculate that, multiply them all together, and it returns a matrix. And just to tie things off, I should go over some of these higher order functions, even though you can get away with using only map and init and sums if you really want. But the first one is array.collect, which will apply a function and collect all of the results that pass that function. But the caveat is that it wants this function to return an array, which is a little weird. So you can also use the filter function to do something similar, but doesn't need to return an array. But depending on your use case, maybe the collect would be a better option. Similarly, you can use array.fold to add together every element of the list. If you do it with a plus, you could also switch this to a star, and that would multiply every element together. So that could be like a factorial in this case, or you could do reduce. Also, you can replace these basic operations with a more complicated lambda function. So what is this actually doing? Well, as I broke down right here, so the first element 1 gets passed in as I, the second element as j, multiplies them together, and now this value gets passed in as I, and the third element would get passed in as j, multiplied together. Now that gets passed in as I, and the fourth element gets passed in as j, and it collapses it all into a single value. We could have changed this to addition or something more complicated. I'll actually run this code so we can see explicitly what's going on. Okay, so run those two functions, calculate this. It collects all the even terms, but we can filter and do the same exact thing. We can fold our array, just add everything together. We can also reduce it. And let's change that to a plus to see that they're exactly the same. Sure. Change this to a minus now. Run that. Some big number. Oops. But it worked. And then this one, the factorial is exactly 24. So exactly what we expect. we really have some powerful tools at our disposal, but just map and init are very intuitive ways to do all these array operations. So I hope you guys find functional programming interesting, and I encourage you to take a look if you haven't already.